We have lesson 5, operations and scientific notation, that we have started this week. And remember that the prerequisite is write numbers using scientific notation. So we want working with scientific notation. This work is in your math practice and problem solving. As you can see, it's the green paper. We are going to do page 51. Remember that one of the words that we were using is scientific notation. That is a way to express a number as the product of a number greater than or equal to 1, but less than 10, and a power of 10. So most of your scientific notation has to be like, for example, in this case, you have 6.25 times 10 to the 8, or 4.03 times 10 to the negative 7. As you can see, these two numbers are between 1 and 10. It can be equals to 1. It can be equals to 1 or less than 10, like 9.9999 times 10 to the whatever number over there that we are going to review. Okay, so problem number 1, remember that we need to read. Everything is reading in math. And we need to understand the problem. So we have an example. We have that 5 nanobytes is equivalent to 5/1 billionth of a byte, or 0.000000005 byte. 5 gigabytes is equivalent to 5 billion bytes, or in this case, 5 billion is this number with 9 zeros. And so they are asking me to write this number and 5 billion into scientific notation. You have all this theory here that you can read, and it will explain you how to do it. Now, one way that I've been using in this class is, for example, if you write 0.1, 2, 3, 4, 5, 6, 7, 8, and then you have 5. Remember that I mentioned you, if you go to the left, count how many places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to have here 5 times 10 to the negative 9, because you went to the left, to the right. You went to the right, so the exponent is negative. You count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Done. So that's one way. In your book, you have another way that you can follow too. If you think it's easier, go ahead for it. And then we have 5 billion. I'm going to do it here. I'm going to move this one. So you have 5 billion. So it's 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this case, what you're going to do, instead of going to the right, you're going to the left. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So you get 5 times 10 to the 9. That's a 9. And you get exactly the same answer. Remember, if you move to the left, it's positive, the exponent. If you move to the right, the exponent is going to be negative. After those examples that you have here, we're going to answer the question. Number 1 is one of the basic questions that we have. In the example problem, you have 0.005 is equals to 5 times 10 to the negative 9. What is the standard form of 10 to the negative 9? 10 to the negative 9. So in this case, what we are going to do is exactly the same. See this one? You got 10 to the negative 9 and you move 9 units to the right. So in this case, if you have 10 here to the negative 9 is equals to 0 point, and you count 1, 2, 3, 4, 5, 6, 8. Wait. 1, 2, 3, 4, 5, 6, 7, 8. And then you're going to put 1, okay? That's the form. And then you count how many units? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 to the negative 9. Now let's put it in the paper. Remember that you need to put this one in the paper and then turn it in as homework. So in this case, you're going to have 0.1, 2, 3, 4, 5, 6, 7, 8, and 1. 1, 2, 3, 4, 5, 6, 7, 8. I'm making sure my count is correct. So that's the solution. Number 2, write a number that is greater than 1 in scientific notation. It's greater than 1. Explain how you know it is greater than 1. And in this case, remember, if a number is greater than 1, you can have 2, you can have 3, you can have 4, you can have 5 point something. In this case, I'm just going to pick a random number, 5.08 times 10 to the 9. And how do I know that that number is greater than 1? Because this exponent is positive. The exponent is positive. Number 3, explain why you might want to write a very large and very small numbers like the ones in the example problem in scientific notation. We mentioned during the class that when you work with scientific notation, it means the numbers are really big or the numbers are really small. So in this case, you can write here with scientific notation. You do not have to count all of the zeros. Okay? In this case, computations can be easier with scientific notation. Okay, so remember we mentioned usually you don't have to count that many zeros, and you saw me and in class counting 1, 2, 3, 4, 5, 6, 7, 8. With scientific notation, you don't have to do that because you just times 10 to the 9. That means you have 9 zeros that you don't have to count. Okay, so that's page 51. Switch to page 52. So they are asking me to solve problem number 4. Write the numbers in scientific notation, and you have 0.608. Remember that number has between 1 and 9 or 10, less than 10. So in this case, you count. I'm going to do this one with color. I'm looking for a color. I'll use this one, my flower pen. So you count how many times you're going to the right. So 1, 2, 3, 4, 5, 6, 7. So I'm going 7 times to the right. That means the exponent is going to be negative. 6.08 times 10 to the negative 7. That's my solution. Now B, same. 1, 2, 3, 4, 5, 6, 7, 8. Now I went 8 units to the right, so it's 9.2 times 10 to the negative 8. Okay, we went to the right, the exponent is negative. Remember that this number has between 1 and 10, less than 10. Cannot be 10 because this one is 10. So 6.08, 9.2. So that reason why I don't leave it 92, because I need between 1 and less than 10. Now they're asking me to write 2.06 times 10 to the 10 in a standard form. If you have 10 to the 10 is 10 billion. 10 billion, that means you have 9 zeros. 9 zeros and then 1. So in this case, what we are going to do is, here, you have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you multiply 2.06, and you get, in this case, 20 billion, 600 million, okay, after you multiply those ones. So you count your zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, then you multiply times 206 and you get that solution. use the number. Number 5 was a basic problem. This is a basic. Number 6 is a medium problem. It's getting harder. Medium. You have used the information in the table, solve the problem. So you have a country, China, Germany, and Martinique. Estimated population, we know China is one of the biggest countries, really populated with India and the United States and Canada. We have 1,290,000,000 people in China. Then we have in Germany 82,700,000. And then Martinique is 405,000. So this is a really small country. So write each population in scientific notation. Look what I'm going to do. I'm going to count those zeros. So let me use this one. So I'm going to count how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1.39. 1.39. See? 1.39 times 10 to the 9. That was the count to the left. And if you go to the left, the number exponent is going to be positive. Germany, how many times? 1, 2, 3, 4, 5, 6, 7. So it's 8.27 times 10 to the 7 power. Remember, we need to leave this number between 1 and 10, less than 10. So that's the reason why I choose 8.27, not 0.827. So 8.27. Martinique, so I have 1, 2, 3, 4, 5. So it's 4.05 times 10 to the, in this case, 5th power, because I count 5 times to the left. Then there is another question. That reason why it's a medium problem, because you have more than one problem. The population of Germany is about how many times the population of Martinique? Explain your reasoning. This problem, I'm going to say, if you see this one, okay, 8.27 and 4.05, if you multiply 4 times 2, you get 8. So I'm going to say about 200 times. And I'm going to explain why. That's the reason why they're asking me why. In this case, 8.27 is about 2 times as great as 4.05. So it's just an approximation, because 2.27 divided by 4, it will be around 2 point something. So we said 200 times. So it's about 2 times as great as 4.05. Now, how do I know that it's 200 times? Because the exponents, in this case, 10 to the 7 is 100 times bigger or as great as 10 to the 5th power. Okay? So, and look at the difference. What is 5 minus 7 minus 5 is 2. And is 10 to that number, 10 to the 2 is 100. So times 2 is 200. So it's 200 times as big. The population of Germany is about 200 times as big as Martinique. Okay, so number 7 is a challenge problem. It's a challenge problem we're going to have in number 7. The problem says, remember, we need to read, a scientist uses 2.8 times 10 to the 12 cells in one experiment, which is 2,000 times the number of cells she uses in a second experiment. 2,000 times. Okay, keep an eye on that one. Write the number of cells the scientist used in her second experiment in scientific notation. Explain your answer. So in this case, what we're going to do, I'm going to give the answer. So in this case, it's going to be 1.4 times 10 to the 9. And I'm going to explain now, how do I get that number? So in this case, I wrote 2,000 in scientific notation. And then divided the number of cells in the first experiment. Okay, so in this case, what I did was 2.8 times 10 to the 12 divided by 2 times 10 to the 3. Remember that 2 times 10 to the 3 is 2,000. Here, let me see if I can move this one. So 2,000, if you count 1, 2, 3, is 2 times 10 to the third power. So I divide it, and I'm going to explain that one in a minute. Okay, 10 to the 3 to find the number of cells in the second experiment. Now, this is what I did. So I have 2.8 times 10 to the second power divided by 2 times 10 to the 3. Okay, so if you divide 2.8 divided by 2 is equals to 2, okay, it's 1.4 times 10, this is 12, to the 9. So look at this one, 12 minus 3 is 9, and then 2.8 divided by 2 is 1.4, so in this case is 1.4 times 10 to the 9, here, this number, okay? So that's 52. Let's do 53. 53. So we have add and subtract numbers in scientific notation. That's what we did today. So we have this example again. We went over an example like this one in class, and we explained what we did. The exponent has to be the same. So let me go over for those who did not connect in today's class. So I have let me put here, I have 3.8 times 10 to the 5th power plus 2.4 times 10 to the 6th power. And as you can see, the exponents are different. So this one is 5 and this one is 6. I need both to be the same. Now, in this case, we're going to manipulate the biggest exponent, this one. So I'm going to have this one the same. So I'm going to have 3.8 times 10 to the 5th power plus, how do I get 5? So I need to move 1 0, so I need to subtract 1. So what I'm going to do in this case, I'm going to move 1 unit to the right and subtract 1. So I had 24 times 10 to the 5th power. See, I just moved 1 to the right. Remember that if you move it to the right, you get negative. You get negative. So from 6 becomes 5. So now I can add, in this case, 3.8. I'm going to do it here. 3.8 plus 24. This is 3.8. So you have 8.7, 27.8. If you can see it over there, 27.8. So this one is 27.8 times 10 to the 5th power. But remember the definition of scientific notation has to be between 1 and less than 10. So we move this unit back to the left and we add 1 to my exponent. So in this case, I have 2.78 times 10 to the 6th power. In those videos that you have in the Google Classroom, explain those steps. So it's important that you go over those videos and see that's the same result that I have here. So now they are asking me in problem number 1. In the example problem, 2.4 times 10 to the 6 was written as 24 times 10 to the 5. Explain why those expressions are equivalent, why those two are the same. And in this case, they are the same because you can type this one, 2.4 times 10 to the 6. And then what I did is 24, move this unit to the right, so you multiply by 10 to the negative 1, 10 to the 6, 6 minus 1 is 24 times 10 to the 5th power. That reason why it's equivalent. Number 2, James rewrote the problem as this expression, and then he added. Does his method work? And you need to explain. I'm going to say yes, it works. Let's explain. It does not matter which number you are going to rewrite, okay? It does not matter which number you rewrite. Okay? You just have to make sure each power of 10 is written using the same exponent. Then you can add. Okay? So in this case, what he did, let me explain it here. So he had 3.8 times 10 to the 5th power. So instead of going to the left, he went to the right. So he moved this one here, and if you move it to the right, you add 1 to this exponent. So it's 0.38 times 10 to the 6th. And then he added. So then he had 0.38 times 10 to the 6th plus 2.4 times 10 to the 6th, and 0.38 plus 2.4 is equals to 2.78 times 10 to the 6th power. And that's correct. Okay, that's correct. Number 3 is a medium problem. Okay, you can use the same method to subtract numbers in scientific notation. Now we're going to subtract. Complete the step to evaluate the subtraction expression. So you have 2.1 times 10 to the 9 minus 9.7 times 10 to the 7. So what we are going to do, see, this one is 2.1 times 10 to the 9. So I'm going to manipulate this one. I need this 10 to be to the 7. So I'm taking 2. So I'm going to move this one 2 units to the right. So I'm going to have 210 times 10 to the 7. See? From here, 1, 2. When you don't have units, you add zeros. So in this case, you're going to have here 210 times 10 to the 7 minus 9.7. So then we subtract 210 minus 9.7 because the exponents are the same. And then 210 minus 9.7 is 200.3. Now, remember, we moved back those ones because we need it between 1 and less than 10. So we move this one 1, 2. So it's 2.003 times 10 to the 9. And we're done. Okay? Number 53 of your, that's the key. Number 54. 54, we're going to evaluate the following expressions. So we have, in this case, this is 9. Okay? Remember that those exponents have to be the same. So I need to move this one 1, 2. Okay? So this is equals to 460 because I moved 2 units times 10 to the 7 plus 1.7 times 10 to the 7. Now I'm going to add these two. So I have 467, in this case, 0.7 times 10 to the 7. So I need to move these ones back. 1, 2, 4.67, 4.677 times 10 to the 9. Okay, that's the answer for that one. Then this one, we're going to subtract. The exponents are not the same. I have 5, so I move 1, so I can have 4. So I have 54 times 10 to the 4 minus 1.4 times 10 to the 4. Now I can add. 54 minus 1.4 is equals to 52.7 6 times 10 to the 4. Then I move 1 to the left, add 1, equals 5.26 times 10 to the 4. Okay? Number 5. In this case, they are asking you, explain one way that you could check your answer in problem 4b. In this case, I can just, I could write the standard form for each number, find the difference, and then compare that difference to the answer I got for problem 4b. In this case, I choose problem 4b. Okay, let's do problem number 6. Find the perimeter of the rectangle in scientific notation. Remember that the perimeter is the addition of every single side. So if this side is 8.2, this one is 8.2 times 10 to the second power. Okay, if this one is 2.4, this one here is 2.4 times 10 to the third power. Now, the perimeter is going to be the addition of those sides. So I'm going to have 2.4 times 10 to the 3 plus 2.4 times 10 to the 3. Remember, I'm doing this 2 plus 8.2 times 10 to the 2. Now I'm doing this 2 plus 8.2 times 10 to the second power. So I'm doing this 2 now. So 2.4 plus 2.4. Why am I adding those two? Because the exponents are the same. So 2.4 plus 2.4 is 4.8 times 10 to the third power. Plus 8.2 plus 8.2 is equals to 16.4 times 10 to the second power. I need to manipulate any of those two. In this case, I'm going to move one unit to the right, and if I move it to the right, I get one down. So I'm going to have 48 times 10 to the second power plus 16.4 times 10 to the second power. Both are the same. So 48 plus 16.4 is equals to 64.4 times 10 to the second power. These are equals. Then remember, move one to the left. So I can have 6.4, a number between 1 and 9. So I have 6.44 times 10 to the third power. Solution. Remember that you have a question. Find the perimeter. The perimeter is 6.44 times 10 to the third power centimeters. That's the unit, centimeters. Okay. Last problem, they are asking me for the area. The area in the Southern Ocean is about 7.85 times 10 to the 6th power square miles. It's an area, so the miles are square. The difference between the areas of the Indian Ocean and the Southern Ocean is about 1.865 times 10 to the 7 square miles. Explain how to find the area of the Indian Ocean, then find the difference. So we're going to explain. So in this case, I'm going to say that I can add the area of the Southern Ocean and the difference between two areas. Okay, so what are those steps? So I'm going to have here, I'm going to type it here, 7.85 times 10 to the 6th power plus 1.865 times 10 to the 7th power. I cannot add those two because this is 6 and this is 7. I need to have the same exponents. So I'm going to manipulate in this case this one, the biggest one. So I move 1 to the right. So this one will be 6. So I have 7.85 times 10 to the 6. I'm writing the problem again. Plus 18.65 times 10 to the 6. Now I have the same exponents. So I add 7.85. I'm going to put it here. I'm going to add 7.85 plus 18.65. See, I'm adding those two times 10 to the 6th power. And this is equals to 26.5 if you add these two times 10 to the 6th power. Move to the left. If you move to the left, you are going to get 1 plus 1 here. So it's equals to 2.65 times 10 to the 7. So in this case, give an answer. So in this case, the area of the Indian Ocean is about 2.65 times 10 to the 7 square miles. And that's the homework for today. Okay, don't forget to turn in that homework. We are now in the second quarter. We're in the second quarter, so we need to submit those assignments so we can get those grades up. First quarter was icky, so let's get those assignments done. I see more participation now. So I hope you have a good day. Make sure you see the video, take notes on your homework, submit the homework, and if you have questions, we have Zoom meetings on check your Google Classroom because period 3 and 5 and 2 and 4 are different. So I will see you next class.